And then number 4, Mr. Alfi Kemal Hisham.
I'm present.
Okay, thank you, Mr. Alfi. Presenter number 5, Mr. Budi Setiawan.
Yes, I'm here.
Okay, thank you, Mr. Budi. Presenter number 6, Miss Sofia Utari Ramadhani.
Yes, I'm here.
Thank you, Miss Sofia. Presenter number 7, Mr. Ahmad Nurhuda.
Yes, I'm here.
Okay, thank you, Mr. Ahmad. And then presenter number 8, Mr. Muhammad Muhaimin. Okay, presenter number 9, Mr. Bowo Susilo.
I'm here.
Okay, thank you, Mr. Bowo.
Yes.
Presenter number 10, Mr. Andri Rustanto.
Yes, I'm here.
Okay, thank
Hello.
you, Mr. Presenter number 11, Mr. Riko Arashid.
I'm represent Mr. Rico.
Okay, I guess you are Vira, right?
Yes.
Okay, thank you, Miss Vira. And then presenter number 12 is Miss Karunia Pasha Kusumawardani.
Yes, I'm here.
Okay, thank you. Then there are 11 presenters for this session. So I will divide it into 2 parts. Part 1 consists of 6 presenters and part 2 consists of 5 presenters. Before we start the presentations, I would like to inform the audience about the general rules of this session. First, each presenter has 8 minutes for presenting their papers. After all the presentation in each part, we will have a question and answer session, and I hope participants in this room will actively ask a question. Participants can write a question in comment box. When presentation, audience must mute their microphone, but it will be good if they activate their web camera. And then, in the end of this session, we will taking a photo for a documentation of this event. So, without further ado, we will start the parallelization part 1. Please welcome Miss Triana Devi Pratiwi from Universitas Indonesia with paper title Cimandiri Estuary Zonation based on sea surface salinity from Sentinel-2 imagery and its relation with the catching spot distribution of Anguilla spp larvae. Ms. Triana, time is yours.
All right. Good afternoon, ladies and gentlemen. Thank you for the opportunity given so I can be here. I am Triana Devi. Today, I want to present to you about my research titled Cimandiri Estuary Zonation based on sea surface salinity from Sentinel-2 imagery and its relation with the catching spots distribution of Anguilla species larvae. So this research was motivated by previous research where Badan Informasi Geospasial in 2018 stated that estuary is a habitat with rich productivity on Earth. The economic potential in this estuary area is dominated by fishery activities. Based on Triatmojo in 1999, estuary is a transition zone between the river environment and the marine environment. According to Fanny System in 1958, estuary zone is determined based on the salinity value, which ranges from 5 up to from 0.5 up to 30 part per thousand. And related to the fisheries activities in the estuary area, there are permanent and temporary inhabitant biota. Temporary inhabitant biota, according to Bleba in 1997, is in the form of adult shrimp and fish larvae. Angulus species larvae is a typical inhabitant in estuary area and can be found in Cimandiri estuary area. According to Irianto, one of the factors that affect the life of Angulus species larvae is salinity. Therefore, the aims of this study is to analyze the Cimandiri estuary zoning based on the sea surface salinity value from Sentinel-2A imagery, and to analyze the catching spots of Angulus species larvae in wet and dry months at the fishing location and its relation to salinity levels. So this research was located in Cimandiri River Mouth, Sukabumi, West Java, Indonesia, and to map the estuary zonation from 2017 until 2020, I used Sentinel-2A imagery and ArcGIS for the whole mapping process. Change the digital number value to top of atmospheric and separate the land and water with extract by mask tool in ArcGIS. Then I apply the sea surface salinity algorithm. In this research, I use Yolamaya algorithm to get the sea surface salinity value distribution map. After that, to map the estuary zone, I done the delineation based on a Fanny system where the estuary zone is the area with sea surface salinity value ranges from 0.5 up to 30 part per thousand. Meanwhile, for a catching spots distribution map, the coordinates for the catching spots was obtained from the interview with Angulus species catcher. In dry month, the estuary area in dry months are 4.34 kilometers square in 2017, 2.04 kilometers square in 2018, and 3.85 kilometers square in 2019. The largest estuary area is in the dry month is in 2017, where the area reaches 4.34 kilometers square, while the smallest estuary area in dry month is in 2018, where the area is 2.04 kilometers square. The difference in the area is related to the rainfall data, where in July 2017, the rainfall data is 199 millimeters per month. But in July 2018, the rainfall data is only 3 millimeter per month. And then next, for the wet month, the largest estuary area in wet month is in 2017, where the area reaches 5.05 kilometers square, while the smallest estuary area is in 2020, where the area is 1.27 kilometers square. For the catching Angular species larvae, the catching was done at night using the tool called ancho. This ancho is a lift nets, where in the dry month, an Angular species larva catcher can get 1 kilogram larvae a day, but in wet month, they can only get 100 to 300 grams larvae a day. The location for catching Angular species larvae is in an area with surface salinity value of 5 up to 15 part per thousand. This is related to the life phase of the Angular species larvae, where in this phase, this is an adjustment of the osmotic pressure between the cytoplasm cells in the Angular species body and the surrounding salinity. Based on the catching location for Angular species larvae, the salinity value of 5 up to 15 part per thousand, which is the mesomesohaline zone or brackish water, is assumed to be a salinity value that corresponds to the habitat of the Angular species larvae. So the conclusion is, in wet month, the largest estuary area is in 2017, where it can reach 5.05 kilometers square, but in dry month, the largest estuary area is in 2017, where it can reach up to 4.34 kilometers squares. The difference between the estuary area in dry and wet month is due to the difference in the amount of rainfall. While the catch of angular species larvae in the dry month is 1 kilogram a day, while in the wet month, it only reaches 100 up to 300 grams at the same location. The catching location for eelfish larvae is in areas with surface salinity values of 5 up to 15 part per thousand. This is related to the distribution of salinity values in a Chimandiri estuary area. In wet month, the distribution of salinity values in a range of 0.5 up to 30 part per thousand is wider, but the catch is less. Meanwhile, in a dry month, the distribution of salinity values in a range 0.5 up to 30 part per thousand is smaller, but the catch of eelfish larvae is more. So this is the references that I use for my research. That is the end of presentation. Thank you very much for your attention.
Okay, thank you, Miss Triana Devi, for the presentation. Such a good and interesting research. And next, we will have Mr. IGEOS Adinugraha from Universitas Pendidikan Ganesha with paper title Please welcome Mr. IGEOS Adinugraha. Mr. Adi, time is yours.
I'm sorry, that's not my presentation. Okay, okay. Thank you. Before I start my presentation, I want to introduce myself. My name is IGEOS Adinugraha from Universitas Pendidikan Ganesha. Today, I want to present my research about critical application of sleep window algorithm, method in forest canopy density, model on Lancet egg only here. Next, for the background about my research, it has three points. In the number one is on SVD model, our process using have three variables to use to for to use to describe the other research, and have the original model of the FCD model. They have four variables, include the thermal index or the split window algorithm. And number two, the information of the thermal index in the FCD model, many research not to have the detail of the information. They have used the thermal index until the land surface or just the brightness temperature. And number three is the FCD model is model from Lancet. For I know this model is good for Lancet because Lancet have the all variable to get in the FCD model. Next. For the literature review, this is the several my literature review. In the literature review, I can explain about the other research. Same with my research in FCD models, they are used three variables and they have accuracy in 84% accuracy. And the Azizi and the Azari model, they have used FCD model with the 4 variable and the get result 80% accuracy above. Next. This is for method in my research for the FCD models. I split the FCD model to have FCD model. In the number one, is the FCD models, they have used 3 variables for advanced vegetation index, their soil index, and shadow index. And the other FCD model, they are completely variable, include split window algorithm or index thermal itself. So the all variable they combine with for the model of FCD. For the analysis, the difference of the FCD model one and the other model. Next, this is the result and discussion. The FCDA, this is the FCD without the split window algorithm, and the FCDB, you can look in the picture. This is the result of the FCD with split window algorithm. So they have the significant result about the settlement area and the high density area. You can look about the table. The FCDA is very much area for the high FCD in the class, and the FCDB they have more not much different with the FCDA. Next. For the validation of the model of the FCD, I in the field survey I used the 50 samples, and the accuracy for the FCD with the split window algorithm, I have accuracy 84%. This accuracy have the other research in Sukarna and the Azari with a value above the 81%. And the FCD model with non-split window algorithm, they have no the accuracy is very low, different with the other research with low and AZZ model. They have 80%. The difference about my result is the other research they use the external variable in the field survey, and my research I use just only FCD go to inject in field survey. So the difference very look indicate in there. Next, this is the conclusion. I think the use of the split window algorithm in the FCD model have a significant impact, especially on the settlement area and the high density vegetation. And number two is the accuracy test of the FCD with split window algorithm model was higher than FCD without split window algorithm, with a 6 difference in accuracy. However, that's not recommended of the use of the FCD model. Only use 3 variables without any external variables. Next, this is the last. I think is the reference for my research. I think it's enough for me to presentation. Thank you.
Okay, thank you, Mr. Sedio Adi Nugraha, for the presentation. And we will continue to presenter number 3, Mr. Alfi Kemal Hisham from Universitas Indonesia with paper Using NDVI, ARPI, MSAVI algorithm for paddy growth test and estimation of rice productivity in Cikakak Subdistrict Sukabumi Regency. To Mr. Alfi Kemal, time is yours.
Thanks for the opportunity. Are my voice loud enough?
Yeah, we can hear it.
Thank you. Good afternoon, everyone. My name is Albi Kemal. It's been an honor to have opportunity to be presenter at 2020 International Geography Seminar. And today I'm going to show you about my research. Title is Remote Sensing Based on Vegetation Index for Monitoring Rice Crop Phenology and Productivity in Cikakak Subdistrict Sukabumi Regency. Here's my introduction. The background of this research is beginning with when the Sukabumi is become the 5th highest rice productivity district in West Java province. And the data is in the line with the Sukabumi Government Plan, which rancangan pembangunan jangka menengah daerah 2016 until 2021, where the Sukabumi Government Plan is to achieve food security and food sustainability. And the agricultural is the priority sector of them. And to be able to achieve food security and food sustainability, of perkalingan and land or earthquake resulting from rapid harvest, so to assist government to in determining policy. And remote sensing is one of the technology that can be used. One of the data can obtain the vegetation index value. For the method, this research using 3 vegetation index, which NDVI, modify SAVI, and ARVI. I'm using their value to see the grain level of the rice field itself. I'm using their value to look the pattern of growth pace in Cikakak sub-district. And for the estimation of rice productivity is built based on the close relation between vegetation index and field productivity. The correlation between NDVI, ARVI, and modify SAVI value is high, which in R2 is 0.86 for NDVI, 0.80 for ARVI, and 0.81 for MSAVI. This is my research area, which there are 34 total in sample point. For the result, this growth pace map for NDVI from January until August 2019. NDVI value is recording to at beginning 2019. The value is range from 0.200 until 0.400, depending on the sample point. And the value continued to rise until February with an average 0.600. The NDVI value fell again in the following month to decrease until it reached lowest point in May. In the following month, the value continued to increase again until August 2019. For ARVI, the value of ARVI itself is negative, different from modify SAVI and NDVI. The value at January until February increasing until Maret 2019 and decreasing until May 2019 and increasing again until Augustus 2019. For modify SAVI, the value is increased to January until February with an average 0.781. And in February, it reached 0.900. And this value will continue decline until May and will increase again until until August 2019. And for the estimation and difference value, the following this table is the result of estimate productivity of tree in vegetation index. The average difference between vegetation index only 0.01 until 3.7 per sample point, with the smallest difference between index is their sample 0.5 with the 0.1 difference ton per hectare, and the largest difference at the 34 point sample at 3.7 tons per hectare. Between the vegetation index, the overall difference between vegetation index is 0.38 for NDVI, 0.64 for MSVI and 0.48 at RIVI, where the NVI has the smallest difference in the calculation of estimation rice productivity. For the first conclusion, the tree vegetation index is produced pattern 2 harvests per year, and distribution it's beginning with at the south part and continue to the west, center, and east, which be the second part, and northern be the last part. For the second conclusion is the relationship between NDVI, modified SAVI, and ARVI vegetation is quite strong. Other vegetation are followed by the ARVI, MSFVI index have the large deviation, and NDVI has suitable vegetation index to be used and estimate of rice productivity in Cikakak subdistrict Sukabumi Regency. That's all my presentation. Here's my reference. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Alfi Kemal, for the presentation. And I'd like to welcome the next presenter. Mr. Ketut Prasetyo, are you ready for presentation?
Okay, thank you. Mr. Chairman, I let's to invite your room too. Okay,
oh, yeah.
thank
I'm
you.
sorry, Mr.
Can you do show my paper and my paper, PowerPoint?
Okay, please wait a second.
Okay.
To operator, we will now presenting PowerPoint from Mr. Ketut Prasetyo. Please display it. I think the operator still search your presentation, sir. So we must wait for a moment.
Okay, thanks.
Yeah, I also want to inform all participants and presenter, if there are any question, you can write and drop your question in comment box.
Dede, Ade.
Okay, please, Mr. Ketut, time is yours. I'm sorry, Mr. Ketut, you still mute your microphone.
Thanks.
Okay.
My title of this paper is Application Remote Sensing and IGEOS and Identification Vulnerable of Groundwater Pollution in Topographic Cars. this paper to write my Ketut Prastyo and Yulinar. This is my student. Is to collect data from location research. Introduction: when cards is potential resources for the large amounts of waters. Water is recruitment, but it's water in topographic cards appears to underground waters. Next, cards about its water potential. Cards, you please, yeah, okay. In cards abundance water potential is equivalent to the rivers that parts makes underground water is cut as vulnerable to pollution. Purpose of the study is I want to detection what is vulnerable water and cut underground water. Why we are going to use remote sensing data and GIS? Remote sensing data is especially to detect land cover, but in the cover is associated with about in the underground water, underground in the water. It is to inflict water when lands cover to damage to pollution underground water in the cards. This is to pollution too. The location my research and at Rengel. Rengel, it is the parts of Tuban district in East Java. This is Kars region. Next. This is literature review on this location. Tirafika Dia Indarti. This is my student. Now this is job in district in Tuban. This is to research too, but vulnerable, but it's groundwater pollution in Kars too. This is parts of region I chose in Rengel. Cahyo Nugroho used to study in Kars Tuban, but it's Yogyakarta special region and Kars Rengel Tuban. He is want to dispatch, identifies expected temporally and differences the degree cards of the course. Eko Budianto, he used remote sensing and geographic information data system available to raise assessment at Gunung Sewu Kars, groundwater, and Gunung Kidul Regency, Yogyakarta. My research application remote sensing to identification vulnerable groundwater population in topographic cars. I want to combine use remote sensing, GIS, and analyze logistic research of to map distribution pattern of each level of level of cars region. Next. This methods I to collect from data primary and secondary data. Secondary data where to collect from environment services data and satellite imagery from the USGS, and primary data we objective from direct files, data observation, the study area files. Data analysis techniques is to study, use image interpretation and logistic regression test which the results of the logistic regression model calculation of compare with a condition obtained from observation measurement of the files. Okay. Next. This research, my research, we shown this is Rengel Kars region shows the distribution pattern of X level of vulnerable in the Kars region. Shows high vulnerable is symbolized in red, and medium vulnerable in yellow. And finally, when you to show low vulnerable with symbol of green. Next. This discussion when you interpretation to certain samples of the source, if the research areas 70 to according skid mode, and when to reference of Budianto, sets of accuracy the assessment can be accepted if the calculate result of a greater. Second, identification, groundwater policy and interpretation, image and using logistic analysis, land cover, presentation of soil cover and thickness with accuracy results of the interpretation of pollution according to the results of vulnerable with 16. This means that it's a research when you means the research is to application. The use of cover vegetation, the study is strongly influenced by the season. In dry season, there is no season, and we right no sorry left source and land condition location. Surrounding district is appears as land cover vegetation. Their cuts rock at crop increase the loss of the cover vegetation. There are many rock embedded lands and slope of the steep slope. Logistic regression analysis have to happening as result interpretation. Now, at last of my research, next slides. Thank you. The vulnerable, when I conclusion, vulnerable assessment groundwater pollution is one alternative effort to protect groundwater quality. Groundwater vulnerable assessment and provide information about this 50 location in my research. This is high level sensitive exchange and human activities at surface of the earth. By interpreting remote sensing data and very useful on identification distribution pollutant source, which then talks to interpretation land uses and the certain location. Furthermore, by carrying of the process weighting, assessment, and mapping using the GIS application, information will be obtained about the space allocation at the highest possible of pollution. The study shows that the average research was classified as vulnerable to pollution. Okay, thank you for your attention. Finally, this is my reference for the support my research and the paper. Thank you, Mr. Chairman.
Okay, thank you, Mr. Ketut Prasetyo, for the presentation. And next, we will have the fifth presenter. Please welcome Mr. Budi Setiawan from Universitas Gadjah Mada with paper titled Probabilistic Projections of Total Fertility Rates for Indonesia and Pacific Region using the Bayesian hierarchical model. Mr. Budi Setiawan, time is yours.
Thank you, Mr. Safira. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hello, everyone. My name is Budi Setiawan. I'm a doctoral student in population studies at Universitas Gadjah Mada. Maybe you can show my presentation, Mr. Safira.
Okay, operator, please display.
Okay.
The upper one. Yeah.
No.
I think it's the second one.
Yes, the second one.
I guess it takes time to display the presentation.
Okay, we'll wait for.
Yeah.
Okay. Today, I would like to present the result about probabilistic projection of total fertility rates for Indonesia and its region using the Bayesian hierarchical model. Next. Current official population projection for the national and provincial level in Indonesia still use a deterministic approach to prepare the assumption of total fertility rate. There are two scenarios of TFR, namely policy and trend scenarios. In the policy scenario, national TFR is assumed to hover at 2.1 since 2020, while provincial TFR is kept at 2.1 once it has achieved this point. As for the trend scenario, it uses a logistic function and projects TFR at the national and provincial level as a decline following the TFR data pattern in the past. The United Nations adopts the Bayesian hierarchical model proposed by Alkema et al. To produce probabilistic projection of TFR for all countries, including Indonesia. Prior scholars have implemented BSM to produce probabilistic projection of TFR at subnational level. Borges initiated the use of this model to project TFR probabilistically at a subnational level in Brazil, followed by Adil and Mazzucco that produced the same projection at the same level in Pakistan. Based on national BSM-based projection, Sevcikova, Refteri, and Gerland produced probabilistic projection of subnational TFR in 47 countries using 3 models, namely scale AR1, and one-directional BSM. All of these scholars confirm that BSM is reliable for making probabilistic TFR projection at the subnational level. In line with the studies mentioned above, this research was designed to make probabilistic projection of TFR for Indonesia at the national and provincial level, using BSM-based projection with 3 prior distribution, namely all countries, Asian countries, and Southeast Asian countries. Next. This research used the TFR estimates for all countries obtained from the WPP 2019 as prior distribution in the BSM-based projection process. For the national and provincial level in Indonesia, the 5-year data were estimated using a logistic function based on actual TFR data collected in the population census and the interchangeable population surveys in different years. This research adopted the BSM proposed by Alkema et al. The BSM had 2 models, a fertility transition model and a post-transition model. The first model was used to estimate the decline parameters in the second phase of TFR evolution, that is fertility transition. It is relevant for the national and provincial TFRs in Indonesia, which continue to decrease to replacement level. The decline parameters of TFR, theta C, are estimated with a Bayesian hierarchical model. As for the second model, it was employed to estimate TFR that oscillated around replacement level in the third phase of TFR evolution, namely post-transition low fertility. In the WPP 2019, 40 countries are projected to have entered the third phase, particularly those with fertility below 2.1 live births per woman, and increased fertility rates for at least 2 consecutive 5-year periods after reaching their minima. The parameter rho and S are estimated with the maximum likelihood estimation based on the experiences of those countries. The 2 models have been incorporated in the R package called Bayes TFR. Next. The 3 BSM-based projections had nearly identical mean average percentage error, which were between 4.05 and 4.17%. It indicates that they can forecast TFR accurately at the provincial level in Indonesia. In terms of precision, the third projection model, with Southeast Asian countries as prior distribution, had the smallest difference between the upper and lower bounds of the prediction interval, namely 0.2 children. For this reason, around 48 and 79% of actual TFR fell within prediction interval with 80 and 95% confidence level, which were lower than the other 2 projections. The second projection, with Asian countries as prior distribution, exhibited nearly identical result to the first one, all countries as prior distribution. Both of these projections can calibrate prediction interval so that upwards of 90% of actual TFR can fall within 80 and 95% prediction interval. Next. This is a probabilistic TFR projection for Indonesia in 2015 until 2050. At the beginning of the projection period, TFR in the official projection was slightly higher than the TFR median of the three projections. Within the projection period, such difference widened owing to the presence of targets in the making of official TFR projection. First, TFR was assumed to hover at 2.1 children during the projection period in the policy scenario. Second, the lower bound of the logistic function was set at 1.96 children, so that TFR in the official projection at the end of the projection period was 1.97 children in the trend scenario. However, TFR in the official projection fell within the 80% prediction interval of two BSM-based projection, with all countries and Asian countries as prior distribution, and the 95% prediction interval of the one using Southeast Asian countries as prior distribution. During the projection period, the TFR median in the UN prediction was higher than the one in the three projection. Such dissimilarity reflects differences in data source and methods used to estimate the 5 years average TFR for Indonesia in the 1950 till 2015 period. Meanwhile, the comparable declining pattern between the TFR median values of the UN prediction and the BSM-based projection in this research represent similarity in the projection model, namely BHM. Next. For the provincial level, at the beginning of the projection period, TFR in the official projection was higher than the TFR median of the BSM-based projection, except for Kalimantan Tengah, Kalimantan Timur, Sulawesi Selatan, and Maluku Utara. The officially projected TFRs of these four provinces were lower than the TFR median in the BSM-based projection. All provinces saw that the officially projected TFRs fell within the 80% prediction interval of two BSM-based projections, each with all countries and Asian countries as prior distribution, except for Jakarta and Sulawesi Tengah. Both provinces saw that the TFRs in the official projection fell within the 95% prediction interval. Meanwhile, the BSM-based projection with Southeast Asian countries as prior distribution revealed that the officially predicted TFRs of several provinces were outside the prediction interval. These provinces were Sumatera Utara, Sumatera Selatan, Bengkulu, Kepulauan Riau, Jakarta, Yogyakarta, Jawa Timur, Bali, Nusa Tenggara Barat, Kalimantan Selatan, Sulawesi Tengah, Maluku, Maluku Utara, Papua Barat, and Papua. At the end of the projection period, the right-hand table, TFRs in the official projection shifted to the 95% prediction interval of two BSM projection, each with all countries and Asian countries as prior distribution. These results were attributable to the different targets set for every province. TFR is kept at 2.1 once it has achieved this point. Sulawesi Tengah was the only province whose officially projected TFR was located outside the prediction interval of two BSM projection. Meanwhile, provinces whose officially projected TFRs were outside the prediction interval of the BSM-based projection, with Southeast Asian countries as prior distribution, were proven to increase in number. Next. Here, the conclusion of this research. First, our research support the use of continent as a prior distribution in BSM-based projection as opposed to all countries, to minimize the effect of pattern formed in developed countries on developing ones. Second, our research assert that BSM-based projection is reliable for the making of probabilistic TFR forecasting at the national and provincial level in Indonesia. And third, our research implies that the TFR produced in the BSM-based projection are recommended for the making of official population projection that is based on the 2020 population census. Next. These are the references we use in our research. Thank you for attention. Okay.
Okay, thank you, Mr. Budi Setiawan, for presenting the paper. And for the sixth presenter, we have Ms. Sophia Utari Ramadhani with paper title The Rice Production of Paddy Fields and Relationship with Elevation Using Sentinel-1A in Subang Regency. Ms. Sophia Utari, time is yours.
Yes, thank you for the opportunity. Can my share screen? Okay. is finished here.
Not yet.
Wait a minute.
Okay, it's display.
Denise, can I start?
Yeah, you can start, Sophia.
Yes, thank you. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Sofia Utari Ramadhani from University of Indonesia, and today I will present my studies about the rice production of pedified and relationships with elevation using Sentinel-1A SAR in Subang Regency. And this, the background of this study, the first is about the agricultural sector, because the agricultural sector % per year. And I choose Subang Regency to the study area because Subang Regency is the third largest rice producer in West Java, and it has a diverse topography with variation in the height of 0 until 1,500 meters above sea level. And the study I use Sentinel-1I data to calculate rice production, where Sentinel-1 image equipped with a synthetic aperture radar or SAR can be used to monitorize that the information obtained not yet abstract by weather condition and cloud interference. And this the method. I use the Google Earth Engine platform for the process Sentinel-1 image data. The date of the image recording used is from January until June 2018 and 2019. Then the results are classified using the maximum likelihood method to obtain data on the pace and area of the rice harvest. The harvest area data is then multiplied by the rice production data from the agriculture agency to obtain rice production. After that, the production data is multiplied by 3 altitude classes. That less than 100 meters above sea level, 100 to 500 meters above sea level, and more than 500 meters above sea level to get the spatial pattern of rice belt and its relationships to the altitude. And this, the results of the study. On the left is classification of reserve space in Subang Regency in 2018 and 2019. With maximum likelihood classification, the black color is the harvest space and the green is the space other than harvest space. Then the data is reprocessed to produce spatial pattern of harvest and non-harvest space in 2018 and 2019. As we can see, the most rice harvests are in April, May, and June in 2018 and 2019, and the largest harvest area occurred in March in 2018 and in April in 2019. Rice harvesting in the northern region is rotated from north to south. This is due to the amount of water available. The rice fields in the south are usually planted earlier than in the north because the water supply from the upstream flows to the south first, so that the harvest time is faster than in the southern part. This is also influenced by the type of irrigation. Rice fields in lowland areas use a technical irrigation system, so planting time is very influential on the availability of water supply. And this is the rice production in 2018 and 2019. As we look, the red one is high production area, which is more than 10,000 tons. The region with the highest production occurred in April in the northern region. In addition, on the graph, you can see that the red line is the amount of production calculated from the image satellite, and the blue line is the amount of rice production from the agricultural agency. The comparison of the number of production results from the image calculation and the from the agricultural I can see is not much difference. Is the productivity quantity is low in the image calculation, so are the official production data, although there are some differences. The value of R square value is 0.58. This means that 58% of the products resulting from the image calculation can be explained by rice production data from the agricultural agency. And this is the spatial pattern of rice paddy production in 2018 and 2019. Rice production at altitudes less than 100 meters above sea level is higher than production in higher areas. Regions on the east and west sites is more productive than those in the central subdistrict. In 2018, subdistrict that had a high amount of production were Ciasem and Patok Besi subdistricts in the red one, and the Pusakagara and Cipunagara subdistrict is the orange one. This is also influenced by the shape of the terrain at a certain height. In the lowland elevation area, the land is flat and wide. Meanwhile, rice field is in highly and mountains height are narrower because they are located between highly slopes. And then the result of production calculation with Sentinel-1 in 3 different altitudes area have a different accuracy. Rice production in areas of altitude less than 100 meters above sea level has greater accuracy than in areas of altitude 100 until 500 meters above sea level and 500 and 1000 meters above sea level. This comparison is seen from the accuracy value in each region. The R-square value in the altitude area less than 100 meters above sea level is 0.57, the largest than the 100 until 500 meters above sea level altitude area of 0.1, and in the altitude area of 500
I will share. Okay, can you see my screen now?
Yes, Miss.
Okay. The first question is from Mr. Andri to Mr. Sidio Adinugraha, and the question is, why significant result obtained on vegetation and settlement cover? Please answer the question, Mr. Adi.
Okay, thank you for the question. Why the significant on my results in vegetation and settlement cover? Because the index thermal, which is still in the algorithm, have have the impact with the difference model. With 3 models without the index thermal, for the combination, the original model of FCG is not completely. So the condition of can be model the variable and index vegetation versus and then index thermal have the full combination and give the significance to vegetation and settlement cover. I think that's my answer. Thank you.
Okay, thank you, Mr. And then for the second question, also from Mr. Andri to Ms. Triana. The question is how to adjust one that capture image to represent one season condition. To Ms. Triana, please answer the question.
Okay, thank you for the question. First, to analyze the estuary area in my research, I divided them into dry month and wet month. The classification for dry month and wet month in this research used the Alderman 1975 classification. After I classified the wet months and dry months, there are several wet and dry months in a year. However, in this research, I focused to analyze the difference for dry month and wet month. Therefore, I chose to I chose the Sentinel-2A imagery from the dry month and wet month, where of them have the significant difference in rainfall data in a year. Of course, actually, it is allowed if I use several Sentinel-2A imagery, but in this research, I want to focus uh, to analyze the difference between dry month and wet month. So I only choose one image to represent from one month. I mean one one classification month for dry month and wet month. Thank you.
Okay, thank you, Ms. Triana, for the answer. And for Mr. Andre Santo, is there any question or the answer from a presenter is enough?
Thank you. That's enough. Thank you very much.
Okay, thank you, Mr. Andre. And then for the next question from Ms. Fira Islami for Mr. Asidio Adinugraha. And the question is, have you used the topographic correction in FCD modeling? Thank you.
Okay, thank you for the question. With my model, I not use the topographic correction in my FCD model because if I use the topographic correction, that is I modified the model. So I just use the original model of the FCD model, which I compare with the FCD with 3 variables model. Maybe the next research, I think that is a good idea. Maybe if you interest about the topographic model correction in the FCD model, I think you can look the other research in Safira Himaya. They research of this topic about the topographic correction in FCD model. I think that is good research. Okay, I think it's enough. Thank you.
Okay, thank you, Mr. Adi. Mr. Adi mentioned my master thesis about FCD modeling and also topographic correction. So, Ms. Fira, is there any question or the answer enough for you?
I think it's enough, Miss. Thank you.
Okay, thank you for the question and also the answer. And now we will start second part. For the next presenter, Uda from Universitas covered physical, spatial, temporal of the growth phase and price varieties using Sentinel-1A radar imagery in Ciasem District, Subang Regency. To operator, please display the presentation. And to Mr. Ahmad, time is yours.
Thank you for the opportunity. Have you heard clear my voice before? Okay, thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Nafi. And Mr. Custio. The research is about the spatial temporal of the growth paths and price varieties using the Sentinel-1 radar in Ciasem District as see. Next. Firstly, I would like to share about rise as food while production only around 6 months. This year's professional to the to is the use of superior rice in India is still considerably very low, with only 30% of farmers use quality and label rice seeds. In the current era, identification of grow paths and rice varieties can monitor through remote sensing technology. Remote sensing is a technology that very advantageous in effective mapping at a large scale to monitor the actual area and doesn't require a considerable cost. One often by using using by the Sentinel-1A radar image. Meanwhile, the Assam district is the largest rice production area in Subang. Subang Regency is the third largest rice production area in West Java in Indonesia. So that is one of the main area for supporting food availability in Indonesia. So the purpose of this research is to analyze the temporal characteristic and spatial patterns of the crop paths and rice varieties using Sentinel-1A radar imagery. Next. Okay, the research using conducted using primary and secondary data. Secondary data obtained from the several relevant agencies, while the primary data is obtained from survey into the field using the random sampling method. The sampling is carried out by grid measuring 1 kilometer times 1 kilometer with 60 sample points. The identification of rice growing paths and rice varieties depends on backscatter value of the Sentinel-1A that correlated with data in the field surface. Supervised classification technique with maximum likelihood algorithm used to classify the grow paths of rice. The classification of the growing paths divided into the 5 agriculture land cover, namely land preparation, vegetative paths, reproductive paths, harvesting or maturation paths, and follow. The temporal characteristic of each rice variety obtained by looking the overall value of the image backscatter during the planting period. Each rice variety has different pattern and characteristic of lifespan. Then carry out the process of grouping the age of rice plant divided into 5 categories to facilitate in the analysis of rice varieties used. There are witty, medium, fast, very fast, and ultra fast categories. Using polygon Tizen can be found the distribution of the rice variety sample point in Jasem district, forming random, uniform, or group patterns. Next. The results show that the rice growth paths in Jasem district period 2018 until 2019 take place for 2 planting periods. Planting period 1 in December until April, and planting period 2 until October. The value of the VH polarization backscatter in rice crop shows an increasing trend from the vegetative to reproductive paths and decreasing after the maturation path. We can see the chart. There is a temporal characteristic of rice growing paths based on the backscatter value. The backscatter value in planting period 1 are higher than planting period 2 because in the second planting period, most of the rice fields were not carried out at the beginning of planting rice simultaneously due to anomalies of water shortage. The temporal characteristic of rice varieties based on the backscatter value vary considerably. The backscatter value will decrease after the maturation pass according to the respective age group. PB42 varieties have a highest and most variation in backscatter value compared to the other varieties. Next. Next slide. Okay. Meanwhile, the spatial pattern growth paths of rice plant in Jasem district for planting period 1 mostly dominated start from the north, then goes to the middle and the south. During the rice planting period 2, the planting process start from the north, from the south, then to the middle, and finally to the north. The spatial pattern of the rice varieties spreading and the rice planting period 1 in next slide, sorry. Okay. The spatial pattern of the rice varieties spreading in the rice planting period 1 in Assam district largely dominated by a fast variety age group, namely in Pari 42, Assam, and about 87% of the total rice field area. In planting period 2, mostly same as the previous period. However, the rise of this group has decreased only 77% of the total area of the rice field, because the farmer we use in Pari 33 variety have increased in this period. The spatial pattern of rice varieties in the first and second planting periods were categorized as a random, with test Z and A about 0.68. Next. Okay, for the conclusion of my research, the temporal characteristic of rice growth paths based on the pH polarization backscatter value in Jackson district from a pattern. Increase the backscatter increase from vegetative to reproductive, because big scatter value in planting period 1 are higher than planting period 2. The temporal characteristic of the rice varieties based on the big scatter value vary considerably. The big scatter value will decrease after the maturation pass according to the respective age group. The spatial pattern of the rice growth pass in the first planting period start from the north to the south. Meanwhile, for the rice planting period 2 start from the south to the north. The spatial pattern of the rice plant varieties in the first and second planting periods were categorized as random, with the dominance of Impari 42, Ciherang, and Mekonga varieties. Meanwhile, the Impari 33 and PB 42 varieties are only spread in some part of the Jaksem district. That's all from me. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Ahmad Nurhuda, for the presentation, and we will continue to next presentation. The next presenter is Mr. Muhammad with paper title Mapping Built-up Area Density Using Normalized Difference Built-up Index or and Urban Index or UI wetland in the city Banjarmasin. To the operator, please display the presentation, and for Mr. Muhammad Muhaimin, the time is yours. Okay, Mr. Muhammad Muhaimin, are you still with us? Okay, I guess there are problems with the connection, and no response from Mr. Muhammad Muhaimin. So it will be better if we continue to the next person first. The next presenter is Mr. Bowo Susilo from Mapping and analysis of housing name in capital area of Kulon Progo Regency. To Mr. Bowo Susilo, time is yours. And to operator, please display the presentation.
Okay, thank you very much for the time given. Can you hear my voice?
Yes, sir, clearly.
Okay. May I use my own presentation, PPT?
Okay.
Or, okay. Okay, there is no problem. Okay. Use, okay, you can use presentation that operator use. Okay. Let me start my presentation. First of all, I will introduce my name. My name is Bowo Susilo from Department of Geographic Information Science, Faculty of Geography, Universitas Gadjah Mada. Okay, this research is about toponym, which is a name of an area. Sometimes we call it a geographical name. Okay, please. Next, please. Okay, a toponym as an identity of a specific location. And oikonym is a part of toponym that focus study on the name of inhabited place. The focus of the study is that oikonym should preserve as a social as well as a regional identity. And this is a point of my research. Kulon Progo is one of the regency in Yogyakarta Special Region. And as a part of Yogyakarta Special Region, Kulon Progo should inherit privileged historical values of Yogyakarta. However, whether the oikonym area could preserve this identity is remain unexplored. Okay, that's why the objective of this research is to explore the typology of housing name and as well as the geographical characteristic of the housing location. Okay, next, please. This is a study area. Study area is a small area around governmental activities. In this research is a capital area of Kulon Progo Regency. Okay, I continue with a data acquisition analysis. This is a 5 step in general. First is preliminary virtual survey, because this research was conducted during a specific situation related to the pandemic of COVID-19. So I prefer to use online geospatial resources. That's why I call it preliminary virtual survey. Then I, again, using online geospatial resources, that is Google Earth Pro, for verification to the preliminary virtual survey result. Then I collecting the literal meaning of the housing names. And again, I use online resources. The next step is I classify the housing names based on generic and specific element. Then, last, I perform spatial analysis to reveal the geographical characteristic of the housing name locations. Next, please. And this is the main result. Okay. I hope that you can see clearly. I'm sorry, this is small because I have to limit my presentation to 10 pages. Okay. First is spatial distribution of housing in the study area. Two map here, you can see. And the second is the typology of housing name. In the table, you can see a various name used by the housing. For example, Bukit Indah, Bumi Progo Sejahtera, Gria, Avi Residence, etc. Those names, then I classify based on generic and the specific name. For example, Bukit Indah Ceria. There is no generic name exists that relate to housing. Bukit is not the name for the housing, as well as Indah and Ceria. So for this housing doesn't have a generic name. It only has specific name, that is Indah Ceria. And based on this point of view, there are three categories of adopted. We adopt the name from foreign languages. And the next is indigenous. There is a local name. We can use Bahasa Indonesia, Javanese, and other languages exist in Indonesia. So we have three categories for generic name: non, indigenous, adopted, hybrid, yeah, combination of adopted and indigenous. And in the right side of the table, that there are a literal meaning of the specific name. For example, Bukit Indah Ceria is a lovely cheers. This is the literal meaning. The literal meaning. Okay. Okay. Next. This is the summary of the typology of the housing names. We have adopted, indigenous, and blended or hybrid, and none. This is the example of adopted for generic name. Regency, residence, villa. This is an example of indigenous. Gria, Kasatrian, Dalem, and Puri. For the blended, the housing use two languages. For example, Gria and residence in the same time. And this is the geographical characteristic of the housing. Average area indicate the size of the housing. So you can make a conclusion from this table that housing with indigenous language usually or in common has a large area or a big size or medium to big size in average. This is other characteristic: elevation, average distance, average road density, and average of slope. Okay, next. Okay, I'm straightforward to the conclusion that from this study, I can conclude that more than 50% of housings in the study area which have generic name use indigenous element, that is local language. They use a local language for naming of the housing. In addition, about 80% of the housing use indigenous element for their specific name. The second point is the word of indigenous language with frequency used as a generic name are Kriya, Kesatrian, Dalem, Persada, and Puri. And the last conclusion is that online geospatial data sources and other type of online resources provide valuable contribution to the study of oikonim. Okay, I think that is the last page of my presentation. You can see the reference I use in this research. Okay, thank you very much.
For presentation, and for the next presenter, please welcome Mr. Alfonso. Integrated method to detect high temporal Landsat images using free and open IGEOS application.
Thank you very much, Ms. Moderator. Can I use?
For operator, you didn't have to
Can you see my slide?
Yes, you can, sir.
And also my voice, is it clear? Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Andrew Santo. I'm from University of Indonesia, and I present my investigation about the using of to develop high temporal Landsat image. So this investigation actually based on the fact that remote sensing is often being used to observe of process is often high temporal image, but unfortunately, it seems difficult to get a high resolution in a good sequence. I mean, in a quite dense in time. That's why some researchers also try to blend or to mix between high temp that probably and mostly has a dense low in spatial resolution. So from both images, then we can get high temporal resolution in high also spatial resolution. So we call it as a blending process. However, the process is not straightforward. I mean, it's need kind of several steps. It is not easy, and also some of the process require high computational process. So it is important also to make some kind of integrated method, so we can just using one click and we can get a high temporal and also spatial resolution image. And we use here as an example is to develop NDVI, develop from Landsat imagery, and we try to develop both high resolution in spatial and also temporal resolution. And for the blending image, we use methods from GAL, and they call it STAR-FM, abbreviation from Spatial and Temporal Adaptive Reflectance Model. Principle, it uses a pair of fine resolution image and a coarse resolution image, and we use, for example, here as a fine resolution image, and modis image from resolution 1. So from both plot-free image, we try to, or the researcher find the statistical relation between both, and the statistical relation then used to develop another high resolution image based on one close resolution image, and in this case we use Modis image. So in the end, we can kind of develop a synthetic image of high temporal resolution, and in this case we use Landsat image. So the processing step actually consists of several process. For example, the standard image preprocessing to reduce the atmospheric noise, and also to adjust the georeference position between both image, high and low spatial resolution. And secondly, to resampling, or to resample both image and align, and we hope with the align pixel we can match the position between both pixel position, and then also doing some relative radiometric calibration. So we try to balance between both image, and finally to execute the algorithm of the blending image. And because we would like to reduce the cost of this development process, then we use free and open source software, and here we use R to make an automatization, and also GIS to handle the spatial data processes. And the other one is also we use Modis reprojection tools, and these three software then used together to develop high temporal and spatial resolution image. And here, as an example, we use NDVI image. And this is the example of the result. So we try to develop a synthetic NDVI image of 14 October 2014 using all these NDVI, and the result
I'm we can't hear your voice. Our other participants can hear Mr. Andre's voice? No.
No, we cannot hear his voice.
We still can't hear Mr. Andre. Mr. Andre, maybe it's technical error with your earphone, so we can hear your voice. Hello, Mr. Andre. Is Mr. Andre left the room, maybe because the connection. Okay, so I guess we should continue to next presenter. Next presenter is Ms. Fira Islami Nur Awaliyah from Universitas Pendidikan Indonesia, and she will presenting the paper with title Applied Geographic Information System for Disaster-Based. Fira Islami, time is yours.
Yes, Miss. Yeah, thank you for the opportunity. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Hello, everyone. My name is Fira Islami Nur Awaliyah from Geographic Information Science Study Program, Department of Geography Education, Universitas Pendidikan Indonesia, Bandung. At the event of the 4th International Geography Seminar and PIT-IGI 2020, I would like to present an article with the title of Applied Geographic Information System for Disaster based on Smong's Local Wisdom. Have a good time for watching. Sorry, I can see my PowerPoint.
It's still loading. Okay.
Okay, thank you. Introduction. Simulurgency was one of the most tsunami on December 26, 2004. It is located approximately 40 kilometers from epicenter of the earthquake, was hit by a tsunami wave with a height of 10 to 50 meters. Catastrophic have left 1,700 houses and a coastal village, devastated total death toll of 7. Smong as a local wisdom, reflecting the tsunami 1907 as lead. The cave the 2000. This research aims to map out the level of and to mitigate the tsunami of similar urgency based on Smong's local wisdom. Smong is a local wisdom in the form of oral stories derived from the experience of their ancestor in dealing with the tsunami disaster. Smong start when an earthquake and tsunami hit Simelu with a magnitude of 7 on Friday, January 4, 1907. Smong local wisdom as a tsunami early warning system implemented by the people of Simelu through Manafi-Nafi as a folklore, Mananga-nanga is lullabies for baby, and Nandong is humming. Method. This research method used as a qualitative method where the data collection techniques come from in the study. To information of use the overall stimulus. Okay, ability level was a low level of 30%. It is support mainly the mean of a more be in similar urgency because it is support by geographical condition. Tsunami that has been created community regarding in the addition. Vulnerability map also can be used as a disaster mitigation tool and planning temporary evac. B. Location. Earthquake occurs, immediately pay attention to change in sea level or river water. If you find the water starting to recede, immediately run as fast as possible from the beach or run to a high place. Bring rice, sugar, lamps, knives, matches, and clothes. And remember the story and pass it on to the next generation. Worries arise when there is not enough time to prepare the intended equipment. To deal with such situation, the is location food consisting of places with powder are for similar. The result of the analysis that have been carried out obtained 19 recommendation points scattered in the similar region. This point will be used as a form of disaster mitigation. This point can also be a reference as a place for temporary evacuation from a tsunami that occurred at C. SMOG as a tsunami disaster mitigation. Reminds me if I'm wrong, because I wanna try to tell you the original SMOG verse. Matuay SMOGya, Ranau ple mehampong, da ase uluda. Singa umengge, maraong si mahawaliana lave si mahatu. Ampangan iya mowi, te ensol ata tapi mare hebau matae manok matae. Ngang ulagu kiama iya ang singa maninggal afel mowi lebi sate nga satyo hampong iya faengata. Semongia ta nenida 10 sampai 15 meter. Mek tai ne semongia afelata. Hebau ato tasang kue ek deta ayo. Sahenga singa nilewan mek delo. In English, the verse has the following meanings. After the smoke subsided, the village returned to the village and found that many people had died. More than half of the villagers died. The estimate height of the smoke wave is about 10 to 15 meters. We find a lot of people, buffalo and chickens died. And some people hang on the coconut tree. And some are stranded on hills with a height of 10 to 15 meters. The fragment of the smoke verse become a reference in the study to determine the level of tsunami disaster vulnerability level. In the verse also mention effort to save yourself from the tsunami, namely by going from the coast to higher place. Even though the height of 10 to 15 meters is still a high vulnerability zone, it is less safe to be used as a temporary evacuation site. However, to provide a deeper understanding, strengthening is needed so that disaster mitigation measures can truly minimize the risk of a tsunami disaster. One of them is by providing knowledge to the people of similar urgency regarding the 20-20-20 principle. The 20-20-20 principle is the principle that can be implemented when an earthquake occurs, especially in the coastal area. The 20-20-20 principle is the result of a research by Professor Ronald Albert Harris from Brigham Young University. This number is a scientific calculation that calculating the duration of the earthquake that occur with the speed of the tsunami arrival and the safe evacuation area. Long before the emergence of a 20-20-20 principle, Song exchange of the people. From how this idea is a fruit that smog is the most appropriate disaster mitigation when facing a tsunami. Smog, which is believed to be a primbon by the general public, has now been proven scientifically. Conclusion. The utilization of geographic information systems are integrated with remote sensing technology in the field of disaster, especially tsunami, provides great benefit in disaster mitigation effort. Smog as a local wisdom related to disaster mitigation is used as a reference so that this exist can be preserved and known by future generation. Smog is also a traditional tsunami early warning system in the midst of limited infrastructure. Okay, thank you all for taking time to listen my presentation. I would like to apologize if there is my mistake, and I want to say thanks for support and advice given by Universitas Pendidikan Indonesia has been a great help in the publication of this article. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ms. Mira, for the great presentations. And we will continue the presentations from Mr. Andri Rustanto because there are technical issues before. To Mr. Andri Rustanto, are you ready to continue your presentation?
Hello.
Yes, we can hear you.
Thank you very much. Apologize. Just conclude that can help everybody that want to develop high temporal and also resolution imagery, and it help probably to reduce a human error because of manual methods usually get people maybe not aware with their job because of tired, and also it can increase the efficiency in handling a large amount of data set. So because of our situation in Indonesia, cloud cover may restrict on Earth surface dynamic that at local scale. It's difficult to get high temporal and also spatial resolution of imagery. Then image blending probably can help this situation and fill the gap. And also probably like a technical problem with the sensor of Landsat, for example, of the sensor that also can be filled with these methods. And also because we use FOSGIS, it also can, and probably it can help to study the dynamic of Earth surface with using a high in temporal and spatial resolution data. Thank you very much for the time, and once again apologize with the technical problem. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Muhammad Muhaimin, are you ready for the presentation?
Okay, I'm ready. I'm presentation
Mr.
in my
Muhammad
research.
Muhaimin will presenting the paper with title Mapping Built-up Area Density Using Normalized Difference Built-up Index or NDBI and Urban Index or UI Wetland in the city of Banjarmasin. To operator, please display the presentation of Mr. Muhammad Muhaimin.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Thank you for opportunity. I can see my PowerPoint.
Oh, wait a minute. To operator, are you there? Okay, Mr. Andri, I'm sorry you still share a screen with us. So please stop the screen sharing. Okay, you can start now, Mr. Muhaimin.
Okay, thank you so much. My research is titled Mapping with of Area Density using Normalized Difference Built-up Index or NDBI and Urban Index UE Wetland in the city Banjarmasin. Author Muhammad Muhaimin, co-author Dini Fitriani, Siddhartha Adiatma, and Desi Arisanti. I'm from Geography Education Department, Faculty of Teacher Training and Education, Lambung Mangkurat University, Banjarmasin, Indonesia. Okay, next presentation. Okay, introduction in research. Number one, increase in population and other activities cause the need for land to increase. The increasing demand for land encourages the development of facilities and infrastructure, include housing, roads, bridges, market, agriculture, and irrigation. As a result, empty land or vegetation turns into land. Two, rapid change in building density make it impossible to use grid survey to monitor change. The utilization of information from remote sensing is a solution for monitoring building density because it can be done quickly, multi-temporal, and cover a large area. The remote sensing method has advanced over mapping with grid survey because satellite image data show the condition of the Earth's surface without visiting the entire location, thereby accelerating the monitoring of land change or mapping of an area. And third, introduction, digital remote sensing image processing for both area density studies requires a spatial transformation to be able to identify the appearance of objects in urban areas. The image transformation model that most effectively distinguishes building materials from natural material actually utilises the near infrared, middle infrared, and far infrared channels because they are sensitive to difference in building material and natural material such as vegetation and exposed land. Okay, next method in research. Research conducted in Banjarmasin City, South Kalimantan Province, with an area of 98.46 km square. The data used for the research are grid data, secondary data in the form of Lancet H. Olay, there's imagery recorded on Agustus 40, 2090, and the RBI map of Banjarmasin City in 2004. Sorry. Data processing in this research is experimentally by building and developing spectral transformation. The spectral transformation use are NDVI and UE. Okay, next. Okay, in this case, we can see on the right side of the map NDVI, and we can see on the left of the map in UI, Urban Index. Okay, next. Research and discussion, the breadth of area density is low covering 1,040x hectare, medium bird area density 2,386 hectare, and high bird area density is 30 hectare. 31 hectare. The density of bird area in Banjarmasin City based on urban index result in 3 classification of bird area density. The bird area density is low of 2418 hectare area. The density of the constructed area is 64 hectare area, and the density of bird area is 5 hectare. Okay, next, accuracy, research accuracy, but when in NDVI classification, transformation, and urban index compared to visual interpretation map, data with class object of X non-bird and bird areas show an NDVI accuracy of 91% and accuracy and urban index accuracy of 92%. There is a difference of 1% greater UI accuracy atau greater urban index accuracy. Okay, next. in this research and discussion. Next, okay, in my conclusion is research. Number one, area density with Banjarmasin city in 2019 based on NDVI transformation. It is so that the resulting value range from 0.7 low width of area density to 0.4 high width of area density, where the urban area spectral transformation range uh, minus 0.5 low width of area density to 0.3 high width of area density. Area density within Banjarmasin city in 2090 in central area of central Banjarmasin district. The area density within Banjarmasin city based on NDVI research in three classification of width area density. The width of area density is low, covering 1,048 hectare. Medium width area density is 2,386 hectare, and high width area density is 31 hectare. The density of width area in Banjarmasin city based on urban index result in three classification of width area density. The width of area density is low of 2,490 hectare. The density of the constructed area is 64 hectare area, and the density of the width of area is 5 hectare. The accuracy between the NDVI and urban index classification transformation compared to visual interpretation map data with class object of each non-width and width area, so and NDVI accuracy of 91% and urban index accuracy of 92% accuracy. There is a difference of 1% greater UI accuracy. Overall accuracy extending 18% indicates very high accuracy. Okay, in this my reference in
Please welcome Ms. Karunia Pasha from Universitas Gajah Mada with paper title Analysis of Urban Heat Island and Urban Ecological Quality Based on Remote Sensing Imagery Transformation in Semarang City.
Can I use my PowerPoint presentation?
Okay, the operator, you don't have to display the presentation because Ms. Karunia wants. Okay, you can start now. Karunia.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello all the audience. I'm a graduate student of Remote Sensing, Faculty of Geography, Universitas Gajah Mada. In this occasion, I would like to present our research with the title is Analysis of Urban Heat Island and Urban Ecological Quality based on Remote Sensing Imagery Transformation in Semarang City. Authors are me and my lecturer, Dr. Iswari Nur Hidayati, SSI MSc. This research was conducted because some reasons. The first is urban physical and biotic heterogeneity can influence the urban climate response. The increase of land surface temperature brings on the urban heat island phenomenon. In urban study, resolution capability of remote sensing imagery is able to extract the land surface temperature changes widely and simultaneously. So the aims of this research are to identify island phenomenon and analyze the ecological condition in Semarang City using Landsat multitemporal data. To reach the aims, we used Landsat 7 ETM Plus in 2002 and the Landsat 8 OLI in 2019. The first steps are geometric and radiometric correction, and then we calculate mono-window algorithm to extract land surface temperature maps, and then we calculate urban heat island analysis to extract urban heat island maps that based on the mean and standard deviation value of land surface temperature maps. And then we calculate urban thermal field variance index to measure the intensity of urban heat island and the thermal comfort. And then the last, we calculate remote sensing ecological index that based on four index. The first is normalized difference build up and pair soil index. The second is the normalized difference vegetation index, and then wetness tessel cap. And the last is mono-window algorithm. Then we integrate for index using principal component analysis. Then we use PC1 and normalize the value. The result are environmental quality maps that has value from 0 to 1 value. And then the first result are land surface temperature maps. Land surface temperature it is found maximum and mean value. The mean value increases until 3.37 Celsius. And then the second result are urban heat island maps. The threshold of urban heat island maps also increased from 31 until 34 Celsius. Globally, the area that was impacted by urban heat island in 2002 was wider than in 2019, but the threshold value in 2019 was higher than in 2002. The urban heat island phenomenon also almost occur in lowland of in Semarang Barat until Kayamsari and some parts of hilly area in Tembalang. And the changes occurred in Mijen sub-district because there were many land cover changes into industrial area and settlement building. And the third result are ecological evaluation maps that has value from under 0 and more than 1.02 from excellent until worse. In 2002, there were two dominant levels of ecological evaluation index. There were excellent and worse. But in 2019, the level of ecological evaluation index are more diverse. Some parts of Semarang occurred ecological degradation caused by the decrease of urban thermal comfort. And then the last result are remote sensing ecological maps. Remote sensing ecological index represents the environmental quality level, which the good quality represents with the high vegetation existence. In 2002, almost of lowland represents almost of lowland Semarang exposed moderate environmental quality. Although the quality is moderate in 2002, it represented the location with exposed urban heat island and high urban thermal field variance index. The fair until poor environmental qualities was industrial area. They were in Ngalian, some parts of Ngalian, and then Tugu and Genuk. While the good until excellent was forest in Mijen and Gunung Pati. In 2019, Semarang City was degrading from moderate until poor level, with land covers were dense settlement, industrial area, impervious surface, bare land, and non-settlement buildings. And then the last is conclusion. In 2002 and 2019, Semarang City was exposed by urban heat island. The mean value of land surface temperature was increased in 2019 and reached up to 3.37 Celsius, so that the urban heat island intensity was stronger and urban thermal comfort was lower according to the high UTFVI and then urban heat island phenomenon and the degradation of thermal comfort during 2002 until 2019 impact on the decrease of urban environmental quality. I think it is enough. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ms. Karunia, for your presentations. And for this session, all presenter has presenting their papers. And now we will have a Q&A sessions. And I would like to share my screen. Question is from Mr. Ketut to Mr. Ahmad Nurhuda. And the question is, what is your methods to measure the accuracy of interpretations and how about the accuracy result of the interpretations? To Mr. Ahmad Nurhuda, please answer the question.
Okay. I would like to answer your question. I'm using classification for classify the group paths, and then for the this I'm use the supervised classification too, but I'm doing the classification with the forming of the rice field. That's all.
Okay, so the method of
for the accuracy, I'm using the Google Earth Engine. So when I downloaded and there is correlate because the correction thermal noise removal, radiometric calibration, and terrain correction had processed before. That's all.
Okay, thank you, Mr. Ahmad Nurhuda. And for Mr. Ketut, is there any question? Okay, I guess Mr. Ketut doesn't respond. So the explanation from Ms. Karunia Pasha, Mr. Susilo. The research is so interesting because heads down with virtual survey and how long is and the
Thank you. Okay, I will strike forward. I take about 2 months, more or less, to conduct the research. And related to your question about accuracy of the data, if you mean positional accuracy, I use only data which available online to obtain name as well as the location of the housing names. If you mean positional accuracy, I didn't do accuracy assessment in this research. But if you mean thematic accuracy, information about the housing name, again, I just rely on online data, which are Google Map, Google Earth, Street View, etc. So the accuracy is rely on the sources. Thank you.
Okay, thank you, Mr. Bowo Susilo, for the answer. And for Ms. Karinia Pasha, is the answer enough for you?
Yes, thank you, enough.
Okay, thank you. And for the third question is from Mr. Asidio, Sir Muhammad Muhaimin. My question is, are you split the class for the NDVI and the UI, and are they have the same value of pixel? Thank you. So, Mr. Muhaimin, please answer the question.
Okay, thank you so much, Mr. Sudio Adi Nugraha, for question. Please wait for answer. Okay, thank you so much for Mr. Sudio Adi Nugraha for your question. Your question, that's good presentation. Thank you so much, Mr. My question is, are you split the class for the NDVI and your index? Are they will have the same value of pixel? Thank you. Okay. Split the class for the NDVI and urban index. For the classification ranks value of NDVI and urban index, I registered the class ranks reference. Okay, thank you.
Okay, thank you, Mr. Muhaimin.
Okay.
Okay. For Mr. Asidio Adi Nugroho, is there any question again, or is it enough?
Thank you.
Then maybe for this session we will have just one question left because the time limit, and we have to break for continue next session. And for the last question for this session is from Mr. Andri to Mr. Budiawan. Question is, how the prediction results could be different, especially predictions on provincial level are not similar. To Mr. Budiawan, answer the question. I'm sorry, Mr. Budi, we can't hear you. We still can hear. Are other participants can hear Mr. Budi?
No, Miss.
No.
Okay, now you can hear me? Can you hear me?
Yes.
Mr. Safira? Yes?
Yes, now we can hear you.
Thank you for your question, Mr. Andri. One of the advantages of using this Bayesian hierarchical method is that we can borrow information from other region, in example, countries or province, to project pattern of decline, pattern of vegetative decline, as well as future uncertainties. However, the result of the TFR projection will differ spatially because the pattern of decline and uncertainty for each province is determined by its own data and data from other regions. That's all. Thank you, Mr. Safira.
Okay, thank you, Mr. Budi Setiawan. Thank you for all participants. And break time for 20 minutes, and we will start the next session at 10 p.m. And please keep joining us, and see you in Assalamualaikum warahmatullahi wabarakatuh.
Provincial IOF and IOM data in Indonesia were estimated using cubic spline interpolation based on the same data derived from the population census and the interchangeable population surveys in different years, which were published by Statistics Indonesia except for EPS 2015. For this year, the IOF and IOM data were obtained by interpolating EMR to IOF and IOM using the West model of the Cold-Demeny mortality table. This research used the GPP model developed by Lelick and Raftery, Lelick and Gerland, with the BSM-based projection proposed by Chun et al. And Raftery, Chun, Gerland, and Sevcikova as the basis. This model consists of two steps, namely BSM-based probabilistic projection of IOF and stochastic projection of the gap between IOF and IOM using the Lelick regression model. And the IOF data derived from the first step as a covariate. As for the probabilistic projection of IOM, this research combined the projected IOF in step 1 with the gap identified in step 2. This GPP model has been previously implemented in the R package term-based life by Sevcikova, Raftery, and Chun. This is the result of sample forecasting. Among the three joint probabilistic projection, GPP with Asian countries as the prior distribution showed the highest accuracy. Mean average percentage error values of the IOF and IOM projection were 1.3% and 1.42% respectively. In terms of precision, this GPP is a smaller difference between the upper and lower bounds on the prediction interval than GPP with Southeast Asian countries as the prior distribution, but wider than GPP with all countries as the prior distribution. At 80% confidence level, it produced difference amounting to 4.36 and 4.7 for years between the upper and lower bounds for IOF and IOM projection. Furthermore, it had similar coverage to GPP with Southeast Asian countries as the prior distribution. Around 84.85 and 87.88% of actual IOF lay within the prediction interval with 80 and 95% confidence level. Meanwhile, 87.88% of actual IOM was within the 80% prediction interval. This is the result of probabilistic projection of IOF and IOM for Indonesia for the period 2015 until 2050. In the left side is GPPs with all countries as a prior distribution. The center is the GPPs with Asian countries as prior distribution, and the right side is the GPPs with Southeast Asian countries as the prior distribution. In the 2015 till 2020 period, the officially projected IOF was lower than the median IOF projected by the three GPPs. GPP with Asian countries as the prior distribution, so the lowest difference between the two IOF estimates. Similarly, the officially projected IOM was lower than the median IOM, but the difference between the two was smaller than the difference in IOF. At the end of the projection period, 2045 till 2050, the three GPPs of IOF and IOM deviated further from the official projection because the latter applied to targets during the process. First, EMR was assumed to decrease by 3% per year during the projection period. This is a policy-based scenario, and this most likely affect the official projection because the resulting IOF and IOM are the product of IMR interpolation using the West model of the Cold-Demeny mortality table. Second, the lower bound of the logistic function was set at 16 children per 1,000 live births, so that the official estimate EMR at the end of the projection period increased to 16.21 children per 1,000 live births. Nonetheless, the officially projected IOF and IOM lay within the 80% prediction interval, and this IOF shifted into the 95% prediction interval. From 2015 until 2050, the median IOF and IOM in the UN's projection are lower than the three GPPs. The result reflect differences in data source and method used to produce 5 years IOF and IOM estimates for the 1950 till 2015 period in Indonesia. In 2050, the two types of projection differ less significantly except for the IOM produced by GPP with all countries as the prior distribution. And this is a probabilistic projection of
I'm sorry, one minute left.
Okay. In the 2015 to 2020 period, the officially projected life expectancy of women lay within the prediction interval of the 3 GPPs, except for Papua and Papua Barat, outside the interval. And this is a probabilistic projection of EOM at the provincial level for the period 2015 and 2050. And here is our conclusion. First, the research support that the use of continent rather than all countries the price distribution in GPP so as to minimize the effect of pattern from in developed countries on developing ones. Second, this research confirmed that GPP is reliable for creating probabilistic projection of life expectancy of women and men at the national and provincial level in Indonesia. And third, overall, this research implies that joint probabilistic projection is highly recommended in producing IOF and IOM estimates for the official population projection based on the 2020 population census. These are the references we use in our research, and thank you for your attention. Thank you, Mr. Safira.
Thank you, Mr. Budi, for the good presentations. And for the second presenter, we have Ms. Risma Sari Septianingrum from Universitas Gadjah Mada with paper title Morphometric Analysis Using Geographical Information System Techniques in Serpeng and Sumurop Watershed. To Ms. Risma, time is yours.
Alright. Good afternoon, ladies and gentlemen. Here I am Mas Hari Septianingrum from CAS Research Group Faculty of Geography Universitas Gadjah Mada. Here I will present my research about morphometric analysis using geographical information system technique in Serpeng and Sumurop Watershed. Safira, apakah mendengar suara saya?
Iya, terdengar.
Oh ya. Jadi saya mulai lagi dulu. Good afternoon, ladies and gentlemen. Here I am Risma Sari Septianingrum from CAS Research Group Faculty of Geography Universitas Gadjah Mada. I am here will present my research about morphometric analysis using geographical information system technique in Serpeng and Sumurop Watershed. For the introduction, we know that increasing population puts the demand of water resources in this earth, and karst area as one of landform on Earth surface has vital role in provision water resources for about 20 until 25% of the global population. Allogenic system is a water supply to the groundwater river in karst area, which is in the study, Serpeng and Sumurop are allogenic rivers in Wonosari Basin that supplies water to Gunung Sewu karst area. And water in karst area had a border water management and had influence to hydrology behavior. So morphometric analysis has an effective way to show the basic information about hydrogeologic, erosion, and also potential water. Next. In this study, I'm use method. First, I'm use remote sensing data. I'm use SRTM with 30 meter spatial resolution to identify and analyze the valley network boundary. And I'm analyze the valley network boundary. Here I'm using ArcMap version 10.4. And to classification of the valley network boundary, I'm use classification for D. And for classification of the stream order, I'm use the Tahler method. And here I also use Microsoft Excel to calculate some watershed parameter from spatial data results. So morphometric is carried out through the calculation of areal, linear, and also relief aspect of the watershed. Next. Next. For result and discussion, we know that Sumuruf have a larger watershed than Serpeng. That indicated that Sumuruf had a greater volume from rainfall input and also peak discharge. And Sumuruf have longer main river than Serpeng. That it indicated longer travel time to distribute the water from upstream to downstream. Please, slide before this. And from the stream order, we know that Serpeng have the highest order. It starts level stream order with oval shape, and Sumuruf have fourth level stream order of the highest order with elongated shape. And the stream order have indicated that Sumuruf had bigger river branch, bigger peak discharge, and also bigger flow speed. Next. And then for the average slope, to both stream have the flat drop. Slide before this. Before conclusion. That's it. And the average slope, no, down. Result and discussion. Result and discussion. Stop. Thank you. And for the average slope of the two watershed was flat categories, and have river density is classified on medium category. It goes to both upstream has one formation geology, that is Wonosari formation, and the river density indicating that the two both of watershed have moderate resistance and high sediment, and it have susceptible to flooding and also erosion process. And the bifurcation ratio in Serpeng watershed so low in first order, that is 1.24, and high in the second order is 17, while the Sumuruf watershed has stream order with bifurcation ratio 3.29 to stream order 1, 2.13 to stream order 2, and 0.28 to stream order 3. The bifurcation ratio is indicated that this area is uniform. Serpeng and Sumuruf area have uniform because its dominant bifurcation ratio is less than 5 and have the uniform geological with limestone material. Next.
One minute left.
And the conclusion is the study of morphometric watershed is a vital role in analyzing the hydrologic behavior of Serpeng and Sumuruf Allegany River, and remote sensing and geospatial technique an effective tool to analyze the watershed morphometric. And the results show that the average slope of two catchment was flat categories. The size of the Sumuruf River catchment area is much bigger, namely 42.18 kilometers square, with the main river being 21.44 kilometer, while the Serpeng River catchment area is 10.58 kilometers square and the main river is 8.85 kilometers. The river density of both of them is classified as medium category and the highest order of Murup is fourth level stream order and Serpeng is third level stream order. And the watershed of Serpeng has an oval shape while the Sumurup watershed has an elongated shape. This is my reference. I think all is done. Thank you for the attention.
You're welcome. Thank you, Ms. Risma Sari Septianingrum for the presentations, and for the next presenter is Mr. Muhammad Fikri Maulana from Universitas Indonesia with a title Spatial Pattern of Propagation Digital Terrestrial Television System in East Jakarta City. To Mr. Muhammad Fikri Maulana,
Yes.
time is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikri Maulana, a geographer student from Universitas Indonesia. On this occasion, I would like to present my research titled Spatial Pattern of Propagation Digital Terrestrial Television System in East Jakarta City. In 2012, through regulation of Minister of Communication and Informatics number 5 of 2012 on the standard of digital terrestrial television broadcasting, the reception free-to-air adopted the standard of digital terrestrial television broadcasting from part of continental Europe, namely digital video broadcasting terrestrial second generation, which is replaces from the digital video broadcasting terrestrial standard. The digital television broadcasting revolution as the great opportunity to do many things in limited by technology research, finance, and
Hello, Mr. Muhammad Fikri.
by physical object and the physical condition of the earth, causing reflection, make it possible to know how the phenomenon of in different places. Conducted. Hello?
Yeah?
Yeah. Can you hear my
Okay,
voice?
we can hear you now. You can continue your presentation.
Okay. Yeah. The research area in the conduct in the East Jakarta with the analysis unit used in the grid 1 kilometer research. The physical data used in the study in the land cover data obtained from land use of TKI Jakarta to 25,000 scale data from Dinas Cipta Karya. Relief data and the direction of slope and altitude are obtained from the Dam Nasional. Meanwhile, for building height barrier data obtained from NDSM or normalized digital surface model. Data for the propagation of digital terrestrial television system was conducted a field survey using a digital television signal measuring instrument spectrum analysis settling WS 6980, which is can measure data on the strong signal value, CNR value, and MER value. The data obtained among the 63 sample point based on the grid 2 kilometer taking account variation in the characteristic of the variable used. Then the interpolation analysis is performed by Kriging interpolation using ArcGIS 10 software. Then the physical data and propagation of digital terrestrial television system data in carry out overlay method that are the used for analysis with the correlation analysis method. Thus, it can be known that the physical data affect the variation in value of propagation of digital terrestrial television system. And the result of this study in the propagation pattern of digital terrestrial television system, which is a representation of the strong signal value pattern, has the class classification dominated by the moderate signal with the area 74.66 kilometer square, whose pattern is spread randomly in the center and the northeast area of the East Jakarta City. And in the comparison of the field survey data and with link budget calculation method, it can be known that there are 60 grid in 1 kilometer. They are the same class classification of total grid, which is 231 grids in 1 kilometer. So in the percentage of the class classification, similarly based on the grid 1 kilometer is 25.97%. This percentage values that to them that the link budget calculation method is quite widely used to know that strong value of the signal is not much aligned with the one in the field. In the analysis of correlation of physical condition data on the region to propagation influence data terrestrial television system use the T-square method and the percent per one method, the result showed that the physical data affect the propagation of digital terrestrial television system is altitude variable and bolting height barrier. And the conclusion is the propagation pattern of digital terrestrial television system, which reputation the strong signal value pattern, has class classification dominated by moderate signal with the area 74.66 kilometer square, was the pattern is spread randomly in the center and the northeast areas is Jakarta City. The comparison between the calculation of link budget and the result of the field survey has the similar class classification with the percentage of the 25.97%. And the last conclusion is based on the analysis correlation of the physical condition region of the propagation pattern digital terrestrial television system, only altitude and bolting height barrier have the correlation on the propagation pattern digital terrestrial television system with the 5% of level of significance. This is my reference from this research. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Muhammad Fikri Maulana, for the good presentations. And for the last presenter in this session, we will have Ms. Rahma Kurniastin Utami from Universitas Gadjah Mada with paper title GIS Network Analysis to Optimize Zoning System Implementation for Public Junior High School in Yogyakarta City. To Ms. Rahma Kurniastin, time is yours.
Okay, Ms. Safira, can you hear me?
Yes, I can hear you clearly.
Okay, if you don't mind, I would like to use my own presentation.
Okay, please.
Okay.
Operator, you don't have to display the presentations of Ms. Rahma. Okay, Ms. Rahma, you can share screen.
Okay. Can you see my presentation?
Yes, we can see it.
Okay, thank you. Good afternoon, ladies and gentlemen. My name is Rahma Kurniasri Utami, and I'm a doctoral student at Geographic Faculty of Gadjah Mada University. Today, I would like to present our research article is GIS Network Analysis to Optimize Zoning System Implementation for Public Junior High Schools in Yogyakarta City. Okay, the background of this research is the implementation of school zone system policy, which has many obstacles, as you know. The number of prospective students is not balanced with the number of school quotas. Uneven distribution of public schools, spatially and generally, is not in accordance with the settlement distribution pattern characteristics. And then the zoning buffer system technique, which used by many local governments in Indonesia, has a major weakness which is the image of the blank spot area, which is area were not covered by school services. This is some of the literature review I used in this article. I think I used to pass it. So this is the method. So this article is proposed to GIS analyze to solve this zoning problem for school zone, which we use the location allocation analysis of the median and the surface area analysis. So we compared two of these analysis, which result to optimal zone technique for the public junior high school zone system. This research is conducted in Yogyakarta city, which, as we know as the city of education or the city of students. This city has the weakness about zoning system analysis, which is it does not pay attention to the function of the road network. So the buffer system doesn't concern with the function of the network. So it does not reflect the actual condition of student travel from the residence to school, and it causes that blank spot phenomenon. And the location of the blank spot area covers especially the southern region in Yogyakarta city with different intensities. There are sub-districts with a 100% blank spot level, which means that the children in the junior high school ages, 13 to 15 years old in this area will have absolutely no access to public school education services. So because of this, we propose that two model of network analysis. The first one is location allocation analysis of the median model. We use 3 impedance, which is 1 kilometer until 3 kilometers. I think you can see in the presentation, which is if we use the standard in Indonesia, which is the public junior high school should have a 1,000 meters range from residence to school. So I would like to inform that it only covers 37.89% of the demand. So if we use no impedance, if every demand wants to cover, it will need more than 3 kilometers distance. You can see the results of the map. And then the second one is the surface area analysis. You can see in the map the difference of impedance from 1,000 meters to 3,000 meters. This surface area analysis predicted to be better than the buffer zone system because it considered the function of a network with in this research is the network road data. Okay, the conclusion, the location allocation analysis of the pre-median and the surface area models can provide an overview of education services range. The pre-median model will be used more effectively to solve the problem of the school zoning system because each point of demand can be directly allocated to the public junior high school. And the number of public junior high school in Yogyakarta city, as we know, is far from adequate. So the additional schools is urgently needed to optimize the junior high school education services. The next research should pay more attention to the detailed attribute data for network analysis, especially the detailed road network data as the basis for the network dataset. And this research can be continued, can be led to another research with another analysis in order to add the new schools to optimize junior high school education services. This is some of the reference we use in this research. I suppose that's all. Thank you for your attention.
Question. Okay, I guess there are no questions for this session. So, Alhamdulillah, we finished the presentations for all presenters in this session, and now we will have a photo session. So, for all audience and participants, please activate your web camera. Operator, apa sudah siap?
Masih ada yang belum menyalakan video.
Ya, baik. There's still several audience that not activate their camera. I think it's okay. Operator, please take a picture now.
Sudah, Bu?
Sudah? Okay, thank you, operator. We finished all the activities for the session. Thank you to all participants that joined this session. Hopefully what we have done becomes useful knowledge for us all. As the moderator, my team and I apologize for any shortcomings in this session. After these parallel sessions, there will be closing ceremony and IGEOS announcement in main meeting room. Please don't miss it. Bapak Ibu sekalian, untuk kembali ke main meeting room, Bapak Ibu bisa mengklik tombol leave room, tapi kemudian yang dipilih adalah leave breakout room, bukan yang leave meeting room. Silakan setelah ini saya tutup, Bapak Ibu bisa kembali ke main meeting room. Terima kasih atas perhatiannya, kurang dan lebihnya saya mohon maaf. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih kembali, Bu.
Ya.
Iya.
Sama.